All right, integration by substitution. Going to call these things U subs. And the basic concept is we're going to look for the results of a chain rule. I know I'm kind of mixing notation here a little bit. Normally I'd wrote f prime g of x times g prime of x as the result of a chain rule. And then this would have just been f of x out here. But for one reason or another, they sometimes like to use this capital F to mean the antiderivative of little f. And so just to kind of try to be consistent and show you some things they might show you or actually might show up on a test, I wanted to use little f meaning the derivative and capital F meaning the antiderivative. All right, so let's take a look here. So if we have on the inside some little function g of x, which is 5 minus x squared, and on the outside we have its derivative. Inside function, 5 minus x squared, the derivative of negative x squared is negative 2x. So basic concept is this is just the result of some sort of chain rule. So if we bump this cube up by 4, we multiply by its reciprocal, 5 minus x squared to the fourth plus some constant c. You'll realize that if you take the derivative here, the 4 and the fourth will cancel out, the 4 will drop to a 3, and then normally this thing would be multiplied by negative 2x because that's the derivative of the inside, and that's what the piece is you saw here. It was just the derivative of the inside. If I look at almost the exact same problem in a trig representation, I've got, again, let's look at this function here. This inside function here, sine x is g of x, and its derivative is cosine of x. So literally, I have something being done to g of x and multiplied by its derivative afterwards. So by the same token, I bump this up 1, I multiply by the reciprocal front. This is 1/4 sine x to the fourth power plus some constant c. If I did the derivative, I'd wind up right back where I started with. This cosine actually would come around just because it's the derivative of the inside. All right, so many folks change the variables when it comes to this part. So they do what's called U substitutions. So again, let's take a look. We got 3x squared plus 1 to the fourth power times this 6x outside. If you'll notice, the 6x is the derivative of the inside. So they make some sort of substitution with a variable u. U equals 3x squared plus 1. If they take the derivative of u with respect to x, it should be du dx is equal to 6x. Most people write this du on its own and they multiply both sides by this dx, so it just becomes du is equal to 6x dx. So if you'll notice, this piece here is just du. This piece here, 3x squared plus 1 to the fourth, is just u to the fourth. So I've got u to the fourth du, or 1/5 u to the fifth, applying the antiderivative part plus some constant c. And then we can go back in and sub the value of u back in when we're done. Okay? So two things we can do. If we want to bring a constant out front of an integral, we can. And also, anytime we feel like multiplying by 1, we can. And we're going to do this as far as multiply by some reciprocal sometimes, and I'll show you a quick example. So if you'll notice this one right here, if I pick u to be 5 minus x squared, then du is negative 2x dx. And you'll look up here and you go, I see the x, but I don't see the negative 2 part. So sometimes we have to manufacture coefficients. So I go ahead and make it negative 2x on the inside, and I look at the outside and I multiply the negative 1/2. It's reciprocal on the outside. So basically I just multiplied by 1, but on the inside I did change it so that negative 2x dx is just du. And so basically what do I have here? I just have the integral negative 1/2 times the integral of u to the 1/2. So I multiply by the reciprocal, I take care, and at the very end when I'm done, I just multiply by this negative 1/2 when I'm finished. I can go ahead and plug this in and get negative 1/3 5 minus x squared to the 3/2 plus c. Some of you are going, wait a minute, this negative 1/2 should be multiplied by this and by this. This should have been negative 1/2. It's kind of why I wrote c sub 1 here. Negative 1/2 times some constant I don't know is just another number that I don't know. So most people just leave it, say c. They don't bother showing the distribution because they're both unknowns anyway, so who cares? All right. So if we have a definite integral, one that we're going to cover actually today, one with an upper and lower bound to it, what do we do? Well, we still do the same thing. In this case, u is equal to x squared plus 1. This is the most composite part down here. Du is just 2x, so that's just straight up there. This is du is 2x, and I should have said dx here. So this is just 2 to 5 of 1 over u squared du. All right. Now, where'd 2 to 5 come from? We look at the u and we put x's. These are both in terms of x. We have to put them in terms of u. So negative 1 squared plus 1 would be 2. 2 squared plus 1 would be 5. So literally we just plug those x bounds here into this equation in place of x, and we put them in terms of u here. So this is basically 2 to 5 of u to the negative 1/2. This is negative u to the negative 1 evaluated from 5 to 2. And then the fundamental theorem of calculus that you just learned. I take the 5, plug it in the first time, and subtract the 2. Plugged it in the second time, I wind up with an answer. This is the area underneath this curve between negative 1 and 2. Last but not least, we'll call this one hitting the curveball. Hitting the curveball, I look at this and I go, oh man, look at this. I've got x outside, I've got x plus 1, some sort of more composite function inside, and there's no derivatives here. It looks like multiplication, but I don't feel like multiplying x plus 1 out 4 times. It's just be a pain. So what you do is you do a u sub, u equals x plus 1, and then you also solve for x. So if I just subtract 1 from both sides, x is equal to u minus 1. So in this particular case, du is equal to just 1 dx, so it's pretty straightforward. So what do? I state this as u to the fourth, and then this x that's outside, nothing's hanging out with it, I call the quantity u minus 1. So I can just multiply this. I just now go ahead and distribute this. This becomes u to the fifth minus u to the fourth. And we can take the integral of this. This is 1/6 u to the sixth minus 1/5 u to the fifth plus some constant c. Go ahead and plug back in the x plus 1, and we're home. The book will go nuts here. It'll do something like with a 30th in the denominator. It'll factor x plus 1 to the fifth power out and do something crazy with the fractions. I wouldn't sweat it. I think it's insane. I'll go ahead and just leave the homework locked into the chapter 4 notes and homework, and I won't bother going through perhaps all of it here, but here's a few questions that I've worked out ahead of time, and feel free to take a look at those as you need them. Thanks.